talking about ratios and proportions. So we'll start with the ratio. It's the building block for these two concepts. A ratio is when we simply compare two quantities. Compare two quantities. And there's a couple ways we can write this. We could say something like 3 to 5. So for example, maybe there's 3 eggs for every 5 pancakes we make, or 3 rooms and 5 chairs. I don't know. It can be any comparison of any two quantities, right? 3 people get 5 ice creams. And so we're simply comparing two quantities. We'll see it written two ways, 3 to 5, or more commonly, especially when we're actually doing math, we see it written as a fraction, 3 to 5, and that's how we say it, right? So again, it could be relating literally any two quantities. Ideally, they make sense. For every 3 houses, there are 5 people. Every 3 cars on the road, there are 5 passengers. And so a ratio is simply a comparison of two quantities. Now, one thing that we do want to see is that, 3 compared to 5 is the same as 6 compared to 10, right? If we multiply 3 by 2, we get to 6. If we multiply 5 by 2, we get to 10, right? As a decimal representation, both of these are equal to 0.6. So the value is the same, but the quantity is different, right? So, where we have 3 cars and 5 passengers, now there are 6 cars for every 10 passengers, right? The ratio is the same, right? The value is the same for every 6 cars, 10 passengers, but the quantity has changed, right? This is not the same as 7 to 10, right? That is not the same, but the value of these first two ratios is the same, even though the quantity has changed, right? And you could see that the value of ratios is scalable, right? 3 to 5 is the same as 6 to 10. Well, if we continue to add 3 on the top and continue to add 5 on the bottom, our ratios will continue to have the same value, even though the quantity is changing, right? So that's the same as 9 to 15, which is the same as 12 to 20, and so on, right? This is called scaling fractions. And hopefully we can see here that the value, 3 divided by 5, is the same as 6 divided by 10, is the same as 9 divided by 15, and so on. But when we think of a ratio, the quantity is changing, right? 3 cars for 5 passengers, 6 cars for 10 passengers. And you could imagine if this ratio were true, we could think about however many cars are in a whole city, and maybe that will tell us how many passengers, right? This tells us simply a ratio. And this logic of building this ratio, if this, stays consistent, then we can apply it to this idea of a proportion, right? If there are 3 cars for every 5 passengers, then we can ask the question, well, how many cars if there are, I don't know, 1,000 passengers, right? Instead of continuing this list on and on and on until we get to 1,000, we actually learn this technique called cross multiplying. And so I won't write a question mark there. I'll actually just write this x, and x means some number that we don't know yet, right? Now we'll cross multiply, which means literally make a cross here. So it doesn't matter which one you do first. I just like to start from the top down and left to right. So 3 times 1,000 equals 3,000. Our equal sign gets placed in the middle here, and we do 5 times x, which is 5 times x. Now we have an equation, and so this equation is asking the question, 5 times what number will equal 3,000? Okay. Now, to solve this, we take whatever number is attached to the x and divide both sides by that number. Take whatever number is attached to the x and divide both sides by that number. 5 divided by 5 is just 1, so we're just left with 1x. 3,000 divided by 5 is 600. So, if for every 3 cars there are 5 passengers, that means 600 cars would have 1,000 passengers, right? And this cross multiplication practice will work for any proportion, for any single piece that is unknown between 2 fractions, right? So let's look at a couple questions. In one season, and now this is ratios, okay? This is ratios. So these are ratios. In one season, a basketball team won 60 games and lost 20 games. What is the ratio of games won to games lost? So they want to know games won compared to games lost, or games won compared to games lost. And this is pretty simple. 60 games won, 20 games lost, or 60 games won, 20 games lost, right? All right, a mallard duck has 13 ducklings. 5 of the ducklings are male. What is the ratio of male to female? Okay, so we have a total of 13 ducklings. Of those, 5 are male. So how many left must be female? Well, 13 minus 5 equals 8. So there must be 5 male, 8 female. And now it's asking, what is the ratio of male to female? Well, 5 male to 8 female, or 5 male to 8 female. Right? Again, this fraction form is going to be more useful. We're going to see this more often, but you should recognize this colon, 5 to 8. All right, I'll let you try the next 2 on your own. We'll look at a couple proportions. Now, proportions, we will get into word problems, but here we're simply getting used to the technique of cross multiplication. And so, here we go. We cross multiply, right? We draw this cross. So we have 28 times 9. 28 times 9. Let's use a calculator here. Is 252. 28 times 9 is 252. equals the other side of the cross, 7 times n. Now again, whatever number is attached to the variable, we divide both sides by that number. 7 divided by 7 is just 1, so we're left with n, 1n. 252 divided by 7 is 36. Okay? So what it's saying is 28 divided by 36 is the same as 7 divided by 9. Okay? That's what information we've received. And you can kind of see this, right? 7 times what is 28? 7 times 4 is 28. 9 times what is 36? 9 times 4 is 36. When scaled or multiplied by the same number, we get to the resulting fraction. Number 2, maybe you can pause this and try it on your own. Cross multiply, right? This time m times 9, right? That's just 9m equals 36 times 5, or 180. Again, divide both sides by the number attached to the variable. It's okay that it's an m or an n or an x, right? All of these letters are just an unknown number. 9 divided by 9 is 1, so we're left with 1m. And 180 divided by 9 is 20. So we understand now that 20 divided by 36 is equal to 5 divided by 9. Finally, two-thirds is equal to what fraction, right? We're simply kind of balancing fractions here, right? The ratio says 2 for every 3. So if the ratio remains consistent, how many for every 27, right? If there are 2 for every 3, how many for every 27? Well, again, we simply cross multiply. 2 times 27 is 54. 3 times x is 3x. We divide by the number attached to the variable. 3 divided by 3 is just 1x. 54 divided by 3 is 18. So 2 divided by 3 is the same as 18 divided by 27, right? And this really becomes useful when you want to take a sample from a small population, like, I don't know, the fraction of Democrats versus Republicans in a single neighborhood. Maybe you just go around and ask people from that neighborhood, and you find some ratio, and then you can extend the ratio to the entire town, right? It won't be perfectly accurate in real life, but maybe you have a good estimate. What it's also really useful for is cooking. If one recipe provides one serving size, but you have 10 people coming to dinner, you'll have to scale or multiply your ratio of ingredients by 10. And so you have to, have a lot more ingredients, but you want all your ingredients to remain in the same ratio, or else your cooking's going to come out funny, right? Too much butter sometimes makes things too hard. Too much water, it's hard to bake something. It'll be goopy no matter what you do. So the ratio of ingredients needs to stay the same, even when the quantity is changing.